introduction, and then we will get into our lesson for this evening. Again, just a few housekeeping things. We'll try to go till about 7 and then take a break for 15 minutes, and then we'll resume till 8:30. And let me introduce our speaker tonight. Dr. Houts has a PhD in nuclear engineering from the Massachusetts Institute of Technology. He currently serves as a nuclear research manager for NASA's Marshall Space Flight Center in Huntsville, Alabama. Prior to joining NASA, Dr. Houts worked 11 years with Los Alamos National Laboratory, serving in various positions, including team leader for criticality, reactor and radiation physics, and deputy group leader of the 70-person nuclear design and risk analysis group. Professional awards include a NASA Distinguished Service Medal, a NASA Exceptional Service Medal, and a NASA Exceptional Engineering Achievement Medal. Dr. Houts grew up outside the church and was a staunch evolutionist through his early 20s. Dr. Houts and his wife were baptized into the Lord's Church in '99 and have 2 children. He serves as an auxiliary staff science writer for Apologetics Press, and we are thoroughly honored tonight to have you to come and bring us a word about radiometric dating and the date of the earth, and so age of the earth. And so we're really excited about you being with us tonight. And if you want, take a few minutes and tell us about what's going on in your neck of the woods, and what's your mission work recently. I know you've been doing some foreign mission work, and now you're back home, I think. And just tell us what's new with you, Dr. Houts.
Okay, sure. Yeah, and thanks, Daniel. And I feel really honored to get to talk with you guys. What you're doing is fantastic. It's something we really need in the church. So thank you guys for being here. And again, it's an honor for me to get to present. A lot of mission activities. Things really started opening up in May, and so got to go Zimbabwe and South Africa, kind of a May-June trip, and then down in Honduras in July, and then just got back from Peru this past Friday. And it's a really, I think there's a lot of opportunity for the church right now. We're just having just huge attendances, more so than we had before COVID. Just as far as just a lot of interest, a lot of I guess I'd say, not just attendance at events, but also people really wanting in-depth Bible studies. When we were we'd sit down with people, they'd talk for 1.5 hours, 2 hours, and a lot of them were getting, obeying the gospel. So it was, I think, just some real good opportunities that we can be taken advantage of. And so it's so again, just but really, thank you guys for everything you do and you are doing. One of the things wanted to talk about tonight is when we're a lot of people, and the reason I think the 1.5 or 2 hour Bible studies are so important is, at least what we were noticing, and this might just be something that that I just started noticing, may always happen, but usually you can be you're about an hour into a discussion with someone before they'll really start opening up. And so we'd be having the friendliest conversations with people, and I think they're pretty open, and then it'd almost be like a rapid fire. Here's the 5 reasons that I'm not sure I can trust the Bible, or here's the 2 reasons I'm not sure. But you would never, at least me, and again, that's what you guys are probably a lot better than I am. But you can never get there until it takes like an hour. I don't know how else to phrase it. So that's the one thing, is about really trying to get to know people and know them. Enough that they'll be willing to open up, and of course it's just standard. What do they do, and what's their position, and get them talking as much as we can, and then but so everyone agrees things like I shouldn't say everyone. People we were talking to, you talk about like free will, and how the only way we can make even a simple choice is because God's given us a spirit, because the alternative is that we're just a big chemical reaction, and chemical reactions can't make choices. You can, all kinds of analogies. A lot of times use like wood burning in a fire. We'd be just like that if God hadn't given us a soul, because we just be this really sophisticated chemical reaction. And so people catch on that right away. And then when you talk about, we've never been able to make life from non-living material. it's we can make, God's given us the creativity, the intelligence to make, cars and, rockets and airplanes and computers but we can't make life. And so if someone wants to say, well, 3.8 billion years ago, life just made itself. Well, again, it doesn't make any sense. A lot of people realize, okay, yeah, that doesn't make sense. But one of the ones that they can get stuck on is this carbon dating and radiometric dating. And so that's why it's important to go through. And so just want to really say at the start, it is the dates that we get using radiometric dating or carbon dating is totally driven by the assumptions. And so maybe that's like point number one is, all we really measure, like for carbon dating, we're just measuring a carbon-14 to carbon ratio. And then we make a set of assumptions to estimate how old, say a sample is that contains that carbon. For other forms of radiometric dating, there's other isotopes that are used. So want to start out just that mindset, because a lot of times if someone's trying to make a point, on how this somehow refutes the Bible, what they'll say is, oh, we can measure, we have accelerator mass spectrometers now that can really accurately measure the amount of carbon-14 in a sample. That is absolutely true. I mean, we are 100%, we've got equipment now, we can measure, carbon-14 to carbon ratios really, really well. But that's not how you get the age. Another thing we'll talk about is that's actually come back to hurt the atheists, because we know there's carbon-14 now in things that there should not be carbon-14 in. Another way to think about that, and I'll just put this out up front, is carbon-14, its half-life is 5,730 years. So half of it goes away every 5,730 years. And so if you get a sample that has carbon-14 in it that's measurable, it's less than 100,000 years old. Now, it doesn't mean it is 100,000 years old. You just know it's less than 100,000 years old. And the reason that's important is, you can go, I think it's just a marketing thing. You go into a jewelry store and they'll immediately say, oh, this diamond was made 1 billion years ago, because that makes it even more special. Well, that diamond's got carbon-14 in it. And so that right there says, no, you can't put an exact date on it, but it was less than 100,000 years ago. Otherwise, all that carbon-14 would have decayed away. And so a lot of things like that we'll go through. So what I'll try to do is I'll try to stop like a couple minutes for the break to see if there's any questions, but please also interrupt, if I'm just saying something that, just isn't making sense, please jump in, because it gets a little, got some equation, sorry, I'll always joke, this is like the only Bible study where you have exponential equations. So that's, I guess, a claim to fame. But anyway, it's, okay, so starting out here, let me see if I can get my slides to advance. That's the first thing to try to do. Okay, so one of the things first I want to point out is most dating methods indicate the Earth is a few thousand years old. And what I mean by that is we could look at things like how much sediment is on the seafloor. And turns out there's not much sediment. And if you take into account effects of the flood, where there have been a lot of sediment deposited, again, becomes very consistent with the Earth being on the order of 6,000 years old. Usually I'll revert to saying less than 10,000 years old, just to avoid any, because that's really the difference, less than 10,000 versus, billions. And so very consistent there. Bent rock layers, this is an interesting one. When we see rock layers, sediment, there's a lot of times the rock layers will actually have bends in them. So you go to the bottom of the Grand Canyon and you'll have almost like S curves in these rock layers, but supposedly they were laid down, just, millimeter at a time over, and then, millions of years. Well, there's no cracks in those bends. And so what that means is it had to be laid down very quickly and then somehow bent very soon thereafter, because if it really had been millions of years, it would have cracked. You go down there, you can take some of the rock and just crumble between your fingers. So it's a subtle one, but there's really no way you can get these kinds of bends in rock layers if something was laid down gradually over long periods of time. But it'd be very straightforward to see how that could have happened during the flood. Soft tissue and fossils. Now, I like this one because that's almost something a 5 or 6 year old could explain to their teacher. And the reason that's important is, I know you guys can do that in your congregations also. If you ask, you just ask your second graders, did dinosaurs live with men? And every single one of them is going to probably, unfortunately, say no, because that's what they're getting in school. The dinosaurs lived 65 million years ago, and they never, and so, but we see, basically we see everything from, they're even finding red blood cells now, but basically soft tissue in these fossils, and that it won't last more than a few thousand years. And so the reason I say you can almost have a 5 or 6 year old, unfortunately, you go out in the woods and every now and then you'll find an animal that's died, and you basically say that's that's soft tissue. How long do you think that's going to last? And I mean, it's kind of a little bit of a gross discussion, but they'll realize that it actually takes it's a lot to even get those preserved for a few thousand years, in the middle of bones. But they, secular scientists and Christians alike, you section most dinosaur bones now, you're finding soft tissue in the bone that shouldn't be there, couldn't be there if it was more than a few thousand years old. Energy in the Earth's magnetic field is dropping it's an exponential decay. We can go back about 1,000 years and being confident that it's just following an exponential, which is very consistent with magnetic field during creation week, and then decaying as magnetic fields. That's a little tougher for a 5 or 6 year old to explain to their teacher, but it's still it's an important one. Now, helium and radioactive rocks. We'll talk about this probably in the second half of this discussion tonight, or maybe this. So what happens is, when they say radioactive rocks, if you have something like uranium decaying into lead, so that's one of the decay chains that's used for radiometric dating. When the process of uranium-238 radioactively decaying to lead-206, you end up releasing 8 helium nucleus. They're alpha particles. So if you look online, it'll be alpha decay. But an alpha particle is basically a helium atom. And so when that uranium decays to lead, you also produce 8 helium atoms. And so we'll look at these rocks, and typically the way they're dated is they'll say, okay, we'll assume, and a lot of times you read about zircon crystals, and they'll say, okay, when that crystal formed, it had some uranium in it, no lead, but just some uranium in it. And then that uranium decayed to lead, and they'll just look at the current half-life of the uranium and the ratio of the uranium to lead. And it's pretty straightforward, calculation to say, okay, that this is how long it would take at the current decay rate for that amount of uranium to turn into lead, and then so that's the age they report. But the other piece of data you have is there's a lot of helium in those crystals. Well, I can go in the lab and I can figure out how fast helium leaks out of a crystal. It'd be kind of like you could, you take like a helium balloon, kids have a birthday party and you have helium balloons. Well, you notice after a few days, the balloons that were up on the ceiling are now down on the floor because the helium has been diffusing out. And so there's a certain diffusion rate that helium leaves balloons. We also get that through crystals, again, what they're calling radioactive rocks, or, this particular list had as radioactive rocks. And so I can measure how fast that helium would go out of those crystals. And so we'll have some charts, but it's basically, if you use a creation-based model where most of the radioactive decay occurred during creation week or the flood, you predict the amount of helium very accurately. If you assume that decay rate was over, say, the last 4.54 billion years, you're off by, I think it's like a factor of 100,000. So it's one where you can make the prediction, and then the prediction is backed up by the laboratory measurements. So that's so that would indicate, again, the Earth being a few thousand years old. We talked about carbon-14 in fossils, coal, and diamonds. Again, with that 5,730 year half-life, you should not find carbon-14 in any of those places if they were anywhere close to as old as they say, because it would have all decayed away. You can also look at the rate that salt is flowing into the sea, especially taking into account the effects of the flood, very consistent with the Earth being a few thousand years old. And then DNA in ancient bacteria was the only thing interesting about this is it's essentially the same as bacteria today. So it really puts the evolutionists in a quandary. Either that DNA essentially didn't change over, and they'll say some of these bacteria, they'll say, oh, it's preserved for hundreds of millions of years. Well, either that DNA didn't change, which goes against evolution, or of course their dating methods are way off. So that's kind of an interesting one also. So again, most dating methods would indicate the Earth is a few thousand years old. Now, radiometric dating was the last major discrepancy. Now, the reason I say was, I'll give a little bit of background, but basically it's about 2006 is when Stanford and Purdue and Ohio State and a few other universities started reporting fluctuations in their radioactive decay rates of their medical isotopes. And so we'll have some quotes there, but and again, I know this is not your, you probably won't get into this stuff in most of your Bible studies. I'll just say that. But if someone, I guess another takeaway would be if someone says, well, from radiometric dating, we know the Earth is 4.54 billion years old. One important point is, since for the last 15 years, we've known those decay rates are fluctuating, and we'll have some references, if they really get interested, because the point is they're fluctuating now. They're very small fluctuations, but if things are really physically stable right now. So if something that we have no idea why it fluctuates is fluctuating when things are physically stable, then what could those fluctuations have been during creation week or the flood? And that's one, we can brainstorm some more on it. It's hard to go further than that because none of us are ever going to know what it was like during creation week or the flood. We know what the Bible tells us, but at least it's a point that it's an arbitrary assumption that those decay rates have always been constant. And if we allow them to have large fluctuations during creation week and the flood, large compared to today, then that would bring radiometric dating in line with all the other dating methods we have that are indicating they're being a few thousand years old. Okay, so any questions so far?
No, I don't have any.
So, Dr. Houts, this is Dave. I just wanted to see if I understand with regard to radiometric dating. What you're saying is that the fact that there's fluctuation in is it the results or fluctuation in the testing that shows that it brings it back in line with the other testing results?
So it's so there's actually a decay rate. Say a sample has a half-life of say it was like 5 years. Well, what they're finding is there's actually a fluctuation rather than being exactly the same. There's a statistically significant fluctuation, and so if we say it's 5 years, it should always be to the extent of our statistics. It should always be exactly the same. So it'd be like 5.0000 years, and what they're seeing is, and it looks like it's related to a few factors. There's the Purdue, he's the professor emeritus at Stanford. He thinks it's related to neutrinos. There seems to be, they're trying to pattern match, between the sun's rotation. They're trying to pattern match with our distance from the sun. But so there are actual fluctuations in the decay rate. So it'd be just like, say I had, just an isotope that had a half-life of exactly 5.0000 years. It should literally stay 5.000 years. And if it goes to 5.01 and down to 4.99, that's huge from a physics standpoint, because we'd have absolutely no idea how it could do that or why it would do that. And so it's a little more subtle, but that's one of three assumptions that are made in radiometric dating, is that those decay rates are exactly constant.
Thank you.
Okay, great. No, thanks. Okay, so there are different isotopes. Oh, sorry. Go ahead.
Oh. Yes, earlier you had indicated that the carbon dating was driven was based on the C14, the carbon ratio.
Right.
And how do you determine the age?
Okay, so we'll get into those in just a few charts.
Great.
But yeah, it's
Okay.
so we'll go through that. Yeah. But no, thanks. Yeah, this is really it's a really fun topic. So yeah, we'll try to yes. It's easily a several hour talk. So we'll get those pretty quick. So okay. So anyway, with radiometric dating, there's different radioisotopes that are used depending on the type of sample. And so carbon dating requires a sample to have an adequate amount of carbon. Now, you'll hear like volcanoes, a lot of times they're dated, they use a potassium argon for lava flows. And this one is usually, we'll always read about how you'll have lava flows that we saw happen a few decades ago that are date out to be like 3 million years old. And so now most dating labs will say they want you to almost tell them when you think the lava flow was before they'll date it. Now, the reason that one's important is you'll go into some museums, there's like museums down in New Zealand and other places where they'll say, oh, this volcano erupted 500,000 years ago. And it's based on this potassium argon dating. And we know that that dating isn't accurate to even within 3 million years. And so they'll just get a number, but since no one saw it, it probably erupted in, maybe, a few hundred years ago. Since no one saw the eruption, they can't say it's wrong. But the problem is, again, I'll go back and talk about this a lot. You'll have just members of the public, going through that museum, and they'll say, oh, well, that proves the Bible is wrong, because they'll say, oh, yeah, it's exactly 500,000 years old. That stuff bothers me, because whoever puts that up there, they know that the dating method they use isn't accurate to even within 1 million years, and so they'll make excuses for it. So anyway, that's potassium argon dating, uranium, lead, that's zircon crystals like we talked about. And you also get rubidium, strontium, samarium, neodymium, other decay chains are used. Now we'll get into how the radiocarbon dating works. And again, hopefully this will answer the question, or we'll go through this and then definitely stop, make sure it made sense. So basically, you have cosmic rays coming in from outer space. So usually those are like high energy protons, but they can be helium, they can even be iron nuclei. And what happens is it'll interact with nitrogen 14 and cause that nitrogen to essentially generate a neutron that's then captured by the nitrogen. And in the process of capturing a neutron, the nitrogen will lose a proton. So you get they call it a neutron proton reaction. So just think of essentially cosmic rays are converting nitrogen 14, which is most nitrogen, into carbon 14. And so then, and right now it's about 1 in 1.2 trillion. So we'll just use 1 in a trillion just for round numbers. So you end up with about 1 in a trillion atoms are 1 in a trillion carbon atoms are carbon 14 atoms. So then you have trees growing, shows like animals eating grass. It ends up that whatever the ratio of carbon 14 to carbon is in the atmosphere, that tends to be the ratio of carbon 14 to carbon, in whatever is living at that time. And so we're all, the carbon in our bodies, it's about 1 carbon 14 for every trillion carbon atoms in our bodies also. And so then what happens is, since we're basically intaking carbon and have a lot of carbon exchange with the environment, so that's happening while we're alive. It'll be 1 in a trillion. But then once an organism passes away, it's no longer exchanging carbon with the environment, and so it has carbon. And this could be it could be like a tree that's cut down and they make a wooden bowl out of it, or something something using that wood. Well, now that carbon 14, it's decaying. It has that 5,730 year half-life to nitrogen 14, and so but the regular carbon is just there. So that ratio is changing, and so what you essentially have is I'll leave it on this one for just a little longer. What you essentially have is every 5,730 years, that ratio drops by a factor of 2. So you can think of it if say we cut a tree down today, make a wooden bowl out of it, and we measure the carbon 14 to carbon ratio in that wood, it'd be 1 in a trillion. 5,730 years from now, it'll be 1 in 2 trillion. Another 5,730 years, it'll be 1 in 4 trillion. Another 5,730 years, it'll be 1 in 8 trillion. It cuts in half every half-life, which in the case of carbon 14 is 5,730 years. And so, but all we're really measuring is the current ratio of carbon 14 to carbon in a sample. And so the age is extremely sensitive to assumptions, and with carbon 14, it's really sensitive to the assumption of what was that carbon 14 to carbon ratio when the organism died. Which it could be just like a tree was cut down and we made a wooden bowl out of it. Okay, so any questions on how that works? Just the kind of basics, on the carbon 14.
I want to ask just a practical question, Dr. Houts. So in terms of, you mentioned labs have dating. So if you wanted to date a sample, let's say it's a fossil that you find or some artifact or something in an archaeological dig, can you send that to an independent dating like organization and have them look at it?
Yeah, you can. They now a lot of times they're actually they get how to phrase it. They feel like they get burned a lot because people do send them coal and they'll find carbon-14 in coal, or they'll send them diamonds, they'll find carbon-14 in diamonds. And so they'll actually start asking a lot of questions, which is kind of ironic. It's they'll ask you, well, where'd you find it? What's your estimate for the age? And so but yeah, in theory, and the only reason I mention that is there's a individual. I don't know if you've ever heard the name David Reeves. He has I think he has a show. He calls it like Wonders Without Numbers or something. But anyway, so he has a fossil. He's done that a fair amount. And right now he has a fossil that he's wanting to get that ratio measured on, and it's amazing. He'll go to these labs and they basically want him to tell them how old he thinks it is. And of course, the second you say it's a fossil, they're gonna, we wouldn't find any. But there have been enough people that have done it in the past. That's what you do get. Now a lot of people have accelerated mass spectrometers, and you can do you will find the carbon-14, and then it's just a question of the having to go back and show that there's no way that you did the measurement correctly, I guess.
Okay. Thank you.
I shouldn't say a lot of people. I mean, like they're like $500,000 to $1 million pieces of equipment, but I mean, enough. It's not, enough
people have in a garage. Huh?
Exactly. Yeah. And so we'll get to, there's a lot of things that affect this ratio, but when we look at the flood, and this is another point, is when people are yeah.
I'm sorry. The one thing that I'm a little confused with is that if the carbon dating has maximum life with the half-life of 5,730 years, maximum life it would be less than 100,000 years. How can they come up with the millions of years?
So that's where they use these other decay chains. So you're absolutely right. Carbon dating, they'll go back. Usually they'll try to go back like 50,000 years, which is still enough to, I guess you say, discredit, or count. It contradicts the Genesis account. But yeah, for the old ages, they use a lot of times it's uranium, lead, but then they can also use the potassium, argon, rubidium, strontium, or samarium, neodymium. But yeah, you're absolutely right. So technically, carbon dating is really, you can, if you detect carbon-14, it's less than 100,000 years old, which again is actually, that's one of the reasons. We detect carbon-14 in coal, diamonds, fossils, and so that's one of the reasons we know that they're not as old as they might say using some of these other dating methods.
So that then would be the reason that they ask, well, how old you think it is, so that they can sort of predetermine what dating methodology they're going to use.
Right. So that could be a reason. And then, but what we'd really be looking for, what a lot of people are looking for, is if they find a fossil, they want to see, is there carbon-14 in it? And so that's the, because that would say the fossil is very young. I mean, relative to what some fossils say. So say, for example, if you find a fossil and there is carbon-14 in that fossil, it has to be less than 100,000 years old, even if officially the fossil is supposed to be tens of millions of years old.
Thanks.
Sure, thanks.
So you started to mention one other thing about a controversy in 2006. And so is there some consensus these days on dating methods? Like, is there kind of a majority opinion on the accuracy of these things?
Yeah. So with it's ongoing. The research is continuing. I think he's even patenting a neutrino detector based on fluctuating radioactive decay rates, and so it never got too controversial. Everyone it's recognized that they're fluctuating. It's people, there's no one really claiming they know why they're fluctuating, but but the way the controversy was avoided is even some of the articles will say, well, the fluctuations are so small they don't affect our dating methods, and so that's where we come in, just from a biblical perspective, say, okay, yeah, the fluctuations, and they're right, they're small today, but we have no idea why they're fluctuating. And we have all these other dating methods, and of course, the ultimate dating method is the Bible, but if we look at just outside the Bible, we have all these dating methods that are very consistent with the Earth being a few thousand years old. And then I have this radiometric dating where I made the assumption that these decay rates are absolutely constant. But we notice they're fluctuating a little bit today. Then the extrapolation would be that, okay, if they're fluctuating today a little bit, then they could have been fluctuating a lot during creation week and the flood. But that's the one, can't think of a way that's going to be proven. But it is, as we get into it more, it is very consistent with what we see, like the helium, I guess two ones, the helium retention in zircons is very consistent with that. And then also they call them discordances. So you see these different methods that are used. Usually you can only find like one method for dating a sample, but sometimes I think there's some rocks at the bottom of the Grand Canyon where you can date like 3 different methods, and they're just different decay chains, and they all give very long ages, but they're all different, and they all deviate by more than 2 standard deviations from each other. And so that's called discordances in radiometric dating. And so that's also an indication that there's something fundamentally wrong with our methods.
Dr. Houts?
Yeah.
I'm curious whether any of, or what specifically in this science had an impact on your believing in God and creation.
Okay. Yeah, that's oh wow! So that's a really long story. No, but it was really had a lot of Bible believers making very good points scientifically, and so it got to the point where I couldn't just write that off. But it ended up actually one of the guys that was making very valid points, and I couldn't counter what he was saying. But he's also at that time I was an undergraduate at University of Florida, and he was the top mechanical engineering student. So he was actually he was like on the thermodynamics wall of fame. I mean, it was that's kind of like the Heisman Trophy for engineers. I don't know if you, but it's but anyway, and so he we were having, he liked talking about this. One of the keys is he wouldn't compromise. I'd run across like a National Geographic article once that was saying, well, maybe Noah just thought the flood was global, but it's just this huge local flood. And so I was actually all excited. I was like, well, we'll agree on this. And I went and showed it to him, and he said, no, the Bible's clear. It covered the whole earth, so he wouldn't compromise, which was really important. But anyway, one night after we'd been having a talk, he showed me, it was a philosophy professor from it was a different university, had written up this paragraph, and it was basically a profession of faith in evolution and atheism. And he basically was trying to make it so that no one was be allowed to get a science or engineering degree unless they would sign that paragraph. And so I would, I looked at it and I was like, well, of course, everybody signed that paragraph. We all knew it was true. And then, because I was still kind of devout evolutionist at that point. And then it dawned on me that here's my roommate, had basically a perfect GPA, top mechanical engineering student, a philosophy professor would keep him from being able to get a technical degree. And so it's kind of interesting. So it's a culmination of a lot of things, but that's just one of the reasons, just always, we always need to be speaking the truth in love, behaving the way the Bible says to behave, because that's, because it's a culmination of many things. So the evidences were really important for keeping me listening to him, but it was really just it wasn't I guess and again, I should say lots of little things, but that was one that really stuck out, where I really started thinking, hey, maybe I need to be a little bit more open-minded about this. It really wasn't a scientific debate. It was it's a lot of philosophy. And then once someone opens their mind, then all of the science, literally everything we know about science, is consistent with the Bible and refutes evolution. I
Do
mean,
you think that that it is necessary for people of equal levels of understanding to convince scientists, or could the layman, so to speak, convince a scientist?
okay, so I think we definitely all need to obviously be evangelizing everybody. I think the key is scientists thinking like a scientist will convince himself, but we have to encourage them to actually, basically become open to the Bible. And it's just a opinion, or one of the things we can do is, so if we get someone to study the Bible with an open mind, faith comes from hearing by the word of Christ. That's what we need to do. It's getting them to consider it with an open mind. And so if someone says, in this case, it would be, well, I can never believe the Bible because radiometric dating has proven the Earth to be 4.54 billion years old. We need to show them, well, no, it hasn't. And then they might go on to some other reason they won't objectively consider the Bible, or at some point they'll say, well, no, I'll consider the Bible. So I think you get a lot of fake science reported in the news. You get a lot of atheists with scientific credentials speaking as atheists. And so, but where I'm at, working over here at Marshall Space Flight Center right now, it's a large majority of the people I work with believe in God. Now, that doesn't mean they've obeyed the gospel, but it's not this idea that, it's, I guess I'll just leave it that they obviously don't get the press, but if you just, you're just talking to people in the hall and just talking to people in general. So it's not and so it kind of goes back to maybe what we were talking about earlier, is just talk to a person, see what their real concern is. A lot of times, at least with me, they won't tell you for a long time. And that's why I was saying you get an hour into a Bible study. But if someone gets to the point where they say, well, what about, radiometric dating, or what about, a lot of times they'll say, what about carbon dating, which is what was someone else had pointed out, carbon dating isn't what gives us, or gives them these billions of years. And then at that point, that'd be the time to just say, well, let's look into the assumptions and how those dates are arrived at, and go back and show them that it's the dating methods that are consistent with the Earth being less than 10,000 years old, and then a lot of the assumptions in the radiometric dating. So that would be I guess that would be the scenario where just knowing that the radiometric dating is very assumption dependent, and if reasonable assumptions are made, it can become, it is consistent with the Bible. I think that's probably about the level. And then if they really get into it, then they can, of course, I mentioned I had the Apologetics Press website up earlier, and there's a place they could go where we could help lead them to get more detailed information. Okay. No, thank you. Great questions. Okay, so so I'm going to show then how this is done. And so this is just an example. These are the equations that are used. The carbon-14 concentration is sample, and this isn't something we'll need to memorize, but it's just the carbon. It's basically you take the carbon-14 concentration, sample time of death, and it's times e to the negative lambda t. Lambda is defined as 0.6931 divided by the carbon-14 half-life. T is time, E is the base of natural logarithms, and then if you define, just to make it more of an equation, C is the concentration that's being measured, and C naught is the concentration at death, and you get C equals C0 e to the negative lambda t. Okay, so then going on, and I'm going fast because I don't think Daniel's going to give you a pop quiz on this, and we can go back on it, but it's so suppose you had a sample and the C14 concentration was 2% of the atmospheric concentration today. Well, if we use I'll say just uniformitarian atheistic assumptions, basically everything's always been the same. And even the Bible says, they forget about the flood, they forget about creation. So if everything's been the same for millions of years, then, you just go C equals C0 e to the negative lambda t, and you solve the equation. You end up with that sample being 32,330 years old. And so, of course, if something was really 32,330 years old, that's going against the basically going against the Bible. And so, but that was with these uniformitarian assumptions. Now, if we make assumptions of, say, taking into account effects of the flood, and that's something we'll talk about. There's estimates, there's probably over 100 times more carbon buried now than is in the biosphere, and that's a generally accepted assumption. Some people, I think it's about 200 is what most people will say. So if most of that was buried during the flood, that could have a huge effect on that carbon-14 to carbon ratio around the time of the flood. If a lot of the biblically consistent flood models have the oceans being warmed up by the fountains of the great deep, it turns out that's probably the only way we know to trigger an ice age. I think I won't go too far down these paths, but one of the things is if people look at everything from a biblical world view, it all really makes sense. Where people start to struggle also is if they take half from the Bible and half from secular science or atheistic science, then it won't make sense. And so, but anyway, so won't have time to go down that path too much. But if say the carbon-14 sample is 2% of the atmospheric concentration today, but significant effects of the flood, say it was 1/30 of today's atmospheric C14 concentration at the time shortly after the flood, then you use the exact same equations and you end up with a time that could be very biblically consistent. So exact same equations, exact same ratio measured. It's just what was that initial assumption. And so that's kind of the just point I want to make there. It's a lot of it's not so much what the measurement is, it's what's the assumptions that applied to that measurement. Now, some discussion points. I think we've hit a lot of these. How can there be carbon-14 and coal and diamonds that are supposed to be millions of years old? They can't be. How much carbon-14 was originally in Earth? How was it distributed? Obviously, the Bible doesn't tell us that. There's no reason there wouldn't have been carbon-14 in the original creation. But if there was not carbon-14 in the original creation, that in itself would make an artificially low carbon-14 to carbon ratio, because the carbon-14 would take a lot of time to build up. Decay rates accelerated in the past. Now, I mentioned this cosmic rays that today create, and it's kind of fun. We're not sure that that's the only source of how carbon-14 is being created, but we don't know the other sources. There's even trouble getting that to balance. But assuming that's the majority of it, then even just from what is created by the cosmic rays, by spectrum, I mean, what's the energy of those cosmic rays? That actually changes based on the flux, which is kind of the total amount. That changes based on solar activity, because the sun's magnetic field will actually shield the Earth from cosmic rays to some extent. The Earth's magnetic field strength shields us from cosmic rays. And if it shields us from cosmic rays, it keeps the cosmic rays from getting into the atmosphere, which keeps them from producing carbon-14. And as we talked about in one of the earlier slides, the magnetic field the strength energy in the magnetic field is decaying. And then I think related to the flood, you can go even into like the Museum of Natural History in DC, and they'll point to much, much higher CO2 concentrations in the past. Now, of course, they'll put dates, really, really long dates, ages ago. But again, most scientists predict much higher concentration prior formation of coal, oil, and natural gas deposits. And then the other one is CO2 is actually released when oceans warm up. So if the oceans were warm during the flood, what effect would that have? And then, of course, that CO2 could be reabsorbed. So a lot of factors that go into these assumptions. And so just the assumption that the carbon-14 to carbon ratio is the same today, as it was, just forever. It's a very arbitrary assumption, with a lot of reasons to not necessarily believe that. And so that's again, that's kind of the takeaway there. Now, one thing is the flood was the last major catastrophe. And so we would actually expect carbon-14 dating to work pretty well back to within a few hundred years of the flood. So, someone, say they get a sample from the Middle Ages, or say, something from 1,000 years ago. Well, the carbon dating should actually work pretty well on that, because there hasn't been those ratios would have stabilized out after the flood, or if they'd been affected by changing decay rates during creation week or the flood, all that would have settled out. And so really even going back to probably 1000 BC, we'd expect the carbon dating to be pretty accurate. It's only when we get close to the time of the flood where you'd expect a lot of differences. So I want to mention, I should mention that also. That's, again, which would be the, just looking at it as the flood being probably the, it is a very good explanation for why those ratios would change. It doesn't, I always have to be careful. I always try to, things can also be, God performs miracles, but a lot of times God can also use, and the flood, of course, was a miraculous event, but a lot of times God also can use his, the natural laws that he created. And so, it's just had to be, again, don't want to make, be too firm on, yes, this is exactly what happened, because unless the Bible says it explicitly, we don't know if something's exactly what happened.
Dr. Houts, can I ask a question?
Sure, yeah.
So just to, prior to the flood, the belief is that the earth was kind of like, well, I've heard it described as like a terrarium, like an enclosed system. But then when the flood came, the rains fell, the fountains of the deep opened. And so what, carbon wise, in your estimation, what would have happened? What would the carbon environment, how would have been different before versus after? And just, and I know, maybe it's a matter of speculation, but.
Yeah. So it would be exactly, but one scenario that would be very consistent, both biblically and with what we observe today, would be that most of the coal was buried during the flood. And that's, you look at just how the coal seams are laid down. Coal seams are like 300 feet thick. You'll have trees going through the coal seam. So very consistent with that coal being, basically biomass that was buried, during the flood, or settled on the ocean bottoms from, like floating, huge, mass, floating masses. And then, oil and natural gas, also scenarios for those forming during the flood. And so that would have about, say on the order of 100 to 200 times more carbon in the biosphere before the flood than after the flood. And so that would definitely change the CO2 concentration in the atmosphere significantly. Could have been order magnitude higher. And that's I think it's in the Museum of Natural History. And again, it's a very, very, very pro-evolution exhibit. But I think at one point they say they'll even admit it was 15 times higher in the past, versus what it is today. So you could have seen. So that would, but basically that change in ratio would then, could make the especially with CO2 in the ocean waters being released, that's how you could get these very large changes in the carbon-14 to carbon ratio. But yeah, so that is kind of interesting. If we can't just look at if we were to release all of that carbon back into the biosphere, it's not, we might come close to what the pre-flood climate was, but that's hard to tell because there was, probably just, one large continent before the flood. A lot of other things would be different. The mountains wouldn't have been as high, but it is an interesting point. If all that, say we do release all the carbon back into the biosphere, from coal and oil and natural gas, what really would be the end state after all that? And it's very complicated. We're already seeing that, just because you change water temperature, you change CO2 concentrations, you get more trees, you get global greening, you get, that releases water vapor, you get clouds, the clouds reflect energy back into space. It's really, really complicated, problem. So,
yeah, that's interesting.
Scenario. Okay. Okay. And then this is just a few things. Is trying to go out and just, no one really counters this. Like when you say how could it be carbon-14 and coal and diamonds, supposedly millions of years old. Saw one place where they said, well, maybe it was radioactive decay of uranium, thorium, but that's, you just can't. you end up either having to have really, really accelerated decay rates, or you basically end up being in a uranium mine. And so it's and that doesn't even work. So because you still can't explain how you get this in diamonds. So I was just trying to figure out, okay, what would what could so if you mention this to somebody, what are some things they could say? And you can't you can't explain the distribution or anything, even the best ones. Attempts I think that I ran across online. Some people say, well, we don't really use carbon dating for archaeology. It's what we do is we use say they'll look at a pottery style, or they'll look at the residue on pots, like say a piece of pottery, or they'll look at the layer that the pottery is buried in. They'll use that for dating. And so, but it's funny, as you look at that, it always goes back to something like carbon dating or tree ring patterns. And both of those are very affected by the flood or the post-flood climate. So I'll try to give an example. Let's see. It's okay, so if this doesn't show up, let me know. Okay, so I'm holding a pin up here, right? And suppose I sent this pin out, I had it measured, and they said this pin was 100 meters long, okay? So I had this pin. Well, now I can measure my laptop, okay? So you won't be able to see me this, but I go 1, 2. So my laptop screen, it's a little over 2 pins long. So now I can say, well, okay, my laptop is a little over 200 meters, right? Because my pin length was 100 meters. Now my laptop's a little over 200 meters. And then I could put my laptop across my desk, and I could say, well, my desk is like 4 laptops wide. So that would mean my desk is getting close to 1 kilometer. So I got a really big desk, right? But the whole point was, and you could say, well, no, the length of the desk wasn't based on the length of the pin. It was based on the length of the laptop. But since the laptop was based on the pin, that's where the error propagated. So the reason I say that is, when they talk about the they talk about things like the dating methods they use to estimate archaeological dates. They always go back to being calibrated on carbon dating. So if that carbon date is wrong, then all those other dates are wrong too. So if someone says, oh, we found this piece of pottery and it's 20,000 years old, and you say, well, are you sure? And they'll say, oh yeah, because it's in the same layer as the pottery that's 20,000 years old, or it has the same style as pottery that's 20,000 years old. So you have to push a little bit, but it always comes back to this. It's always calibrated. Essentially, it's almost always to carbon dating, because they even have to use carbon dating to look at some of the tree ring patterns. So if there are errors in the carbon dating because the errors in the assumptions, then there's errors in all of those dating methods. And again, you expect them to be reasonably accurate once you get a few centuries past the flood. But some of the civilizations that were popping up right after the Tower of Babel, things like that, the dates can be really far off, because again, it's ultimately calibrated back to carbon dating, at least the initial dates. Okay, does that part make sense?
Yes.
Okay. Okay, then let's. Okay, then the other one is, sometimes let's talk about other isotopes produced by cosmic ray interaction. So the other one, beryllium-10 and chlorine-36, they're very, very dependent on incident neutron energy, which again goes back to that spectrum and flux of the cosmic rays. And they actually peak at different levels than carbon-14. So, and then also the transport mechanisms are very uncertain. Again, just I'd say the advances in true science, and the main one would really be to me, it's the things like accelerator mass spectrometers, being able to find carbon-14 in diamonds and coal, and this kind of our overall understanding, because again, radiocarbon dating fully consistent with the Bible. So then let's maybe we'll just start very quickly on. Let's see. Well, let's see. I don't know. We're going to take a break in a few minutes here, or I'm good to keep going. Whatever you guys want to do. It's so okay. Well, let's then what I'll do is this was actually that was the third session and kind of a summary of sessions, but we talked about the free will. So to me, that's an important one. The fact that we can't choose tells us how we should choose. meaning we can't make a choice unless God gives us a soul. That's amazing how many people that gets them thinking. Can't say that converts them, but just everybody believes they can make a choice. The fact we make a choice means we can't just be material, we can't just be chemicals. And so I've had a lot of atheists will come up after a talk, and at some point I'll ask them, well, did you choose to be here? And they'll immediately say, oh yeah, I could have done 1,000 other things. And then you just go through, well, if you could choose, you have to have a soul. That means only God can give you a soul. So that's, to me, that's an important one. Focused on eternity. Of course, most people realize a really long life on earth is maybe 100 years. That's 0 compared to eternity. In the beginning, God created the heavens and the earth, means God created time as well as heavens and the earth. So by definition, you can't have a beginning or an end. A lot of people, you'll still get asked that question. I know you guys have too. Just, well, okay, if God made the universe, who made God? By definition, God could not have been made because he made time itself. And then let's see. I don't know if we'll get a chance. Hopefully, we'll get a chance to talk a little bit about the Big Bang. But if not, we'll just keep talking about the radiometric dating. And so, let's see. I guess. I'll just introduce with this slide, and then we can again take a few minute break if you guys want to. Or atheism evolution requires the universe to be literally infinitely old, because trillions of years, quadrillions of years, however many years you want, it just can't work. And the infinitely old is just a mathematical trick with infinity, because you can say if given infinity, then anything can happen. But it's really funny. But given a billion years, you can show there's no way any of this would happen. So, true science has proven the universe had a beginning, and so what a lot of times atheists and evolutionists like to do is claim the universe is extremely old. But one point to make is evolution doesn't work no matter how old the universe. Now, this is a quote from Carl Sagan. So this is really interesting. This was the MIT Press from 1973. He says, well, it is clear that one could randomly assemble all the elementary particles in the universe 1 billion times a second for the age of the universe and never get this protein, because he had just said that it's a 1 in 1 followed by 130 0 chance of randomly forming a single protein. Apologetics, that's scientific notation. That's 1 in. Just read that as 1 in 1 followed by 130 zeros. So it's kind of interesting. He says. He himself said, randomly assemble all the elementary particles in the universe. That's, quarks and gluons, even less than protons and neutrons, 1 billion times a second for the age of the universe, never get this protein. So he's basically saying you can't, that goes back to you can't make life. But it's really interesting. Literally, it's like the same page. He goes on and says, there's no doubt about the fact of evolution, but there are still sizable questions on the mechanics of the evolutionary process. And so it's really, really strange. You get that it's in the book. It's all on page 46 of that Communication with Extraterrestrial Intelligence book. So same exact page. He says it's impossible, but there's no doubt about the fact of evolution, because of course in his mind, well, he's right. The alternative is, of course, in the beginning God created the heavens and the earth.
That's amazing. For sure. Did I lose you there?
Oh no, I'm still here. Yeah.
Okay.
Yeah. And we can definitely, if everybody's good, we can definitely keep going if you want to.
Let's take a short break if you want, and we'll come back. You want to come back at 7:18, and then we'll keep trucking if that's okay.
Yeah, that sounds great. Yeah.
Okay.
Yep. All right. Yeah, that sounds good. All right. I'll see you guys about the. If someone admits that their belief system isn't, purely logical or scientific or whatever they want to call it, that's actually can be a step in the right direction.
Yeah, absolutely. Yeah, that's great. Feel free to. This is a great quote. I think I watched you give a presentation where you shared this, and so tell us how you would use this in a conversation with a peer or someone who's scientifically minded.
So a lot of it is, kind of like what we talked about on it's trying to steer the conversation in that direction. Mm-hmm. And so it just depends on what, you know how things lead up. So like the free will one is sometimes a lot easier because you can always just ask somebody, well, did they have a choice to do something, or did they choose to be an atheist? You know, and you, of course, always speaking the truth in love. But if they say they chose to be an atheist, if they really chose, then that proves atheism's wrong. And that one's airtight. It takes a little bit of, if someone really thinks about it, because the alternative, if we don't have a soul, we're just a chemical reaction, which is, you know, literally just like a piece of wood burning in a fire, you know, really sophisticated chemical reaction, but no choice. So with the life from non-life, that's, you know, it's almost, you know, you get to the point where you say, well, you know, where do you think life came from? You know, and then they say, well, the standard canned answer now is, well, 3.8 billion years ago, you know, life, you know, spontaneously arose or something like that. And then you say, well, you know, just that doesn't, you know, doesn't seem scientific, because if we get into it, it's 3.8 billion years. It puts a lot of mystique on it, but you know, it's this, you know, it's pressures and temperatures and chemicals that they're readily available in any laboratory. So it's not like they could, you know, we could postulate any conditions we wanted to 3.8 billion years ago. We can do anything, you know, anything. We can simulate all that in a lab, and no one's even come close. You know, we're getting to the point where we're, you know, we're able to, you know, like try to copy things, but I mean, we're just, the more we get into it, the more we know it couldn't have spontaneously happened.
Yeah, that's interesting. Very powerful too.
Yeah. It's just, but the main one there is I think if someone says they have a choice, and they basically admitted they have a soul, and then if someone, you know, if you know, again, I've never had someone say it was scientific to believe that. So at least they're acknowledging that they have a belief system that is, you know, it's a belief system. So it's something that they should at least think about.
Right. So give us, if I can deviate from the topic for just a second too, in your experience at Florida, at MIT, around the water cooler at NASA, are these type of questions? Are you so deep in the trenches in your in doing the science that you do that sometimes these questions don't arise, or
yeah, it's and that, I think that's a good way to think about it. Is a lot of people, you know, it's true in a, you know, in a very technical career, but it's probably true in any career. They just don't take time to think about it, and that's so that's the other reason. It's almost like we have to create the conversation, but we shouldn't. We just need to be confident in creating the conversation, and by confident, we should be confident no matter what. But usually the response is pretty good. We just have to look for the opportunities. But there will be people. I think we had an individual a few years ago. He worked till he was, I think, 95 years old, and then I think he basically died, you know, like within a few days. I think that's why he stopped working. And so, you know, if someone's working, you know, huge hours, you know, that, you know, it's you know, from a secular standpoint, that's really impressive. You know, really dedicated, hard worker, lots of contributions, but just you know, just obviously, you know, spiritually, just, you know, terrible for him. And so that's again, I guess what I'm getting at there is a lot of times we think a lot of the people that can be hardest to evangelize are the ones that might be really into their work. It's not just people that, you know, kind of the stereotypical people that sometimes we think, you know, quote unquote, need evangelized. It can be someone that's just so into their work that they're putting, you know, 12 hours a day and they couldn't imagine doing anything else. They're all excited about it. And so it's really looking for the opportunity to, creating the opportunity to talk about things.
that's a good way to put it.
Sometimes, you know, you think like airplane conversations. I know you just got off an airplane. Those can be hard because, you know, people, but you can, you know, even just saying, wow, you know, beautiful day out, you know, and then and a lot of times people say, yeah, sure is. And then, you know, yeah, isn't God's creation wonderful? And it's interesting what kind of responses you can get on that one. You know, sometimes usually they'll say, yeah, sure is. You know, that's probably not, you know, I don't think I've ever had someone say they don't believe in God, or they don't. Yeah, but it's at least it puts it out there. But once they say, yeah, it sure is, and then you can say, and that opens up. Oh, do you, do you attend a church, or I mean, you can keep the conversation going that way.
Right. Yeah, absolutely. Yeah, like what you're saying, sometimes it takes a little while to when I was in, and I've mentioned this to the class too, when Katrina and I were in pharmacy school, you're so deep into the sciences, but you don't stop, and pause to reflect on where did it all come from, what's the purpose of it all. Like, there's not really a lot of giving glory to God and what he does in terms of healing the body and the mechanisms that are in place, that we're kind of speeding along with medicines and things like that. Like, it's kind of like you're deep in the trenches, but you got to, you have to make time or pause just to talk about the bigger, more important issues, in my estimation.
Yeah. No, was your experience you'd get a fairly positive response when you did? I mean, do you ever have anybody that just got totally offended, or because I can't say I've ever had anybody that got totally offended if I was able to get on the topic of God, and it's funny because even just like, I know it sounds weird, but even just going out to lunch or dinner when you're on travel and not drinking is actually a great conversation starter. Everybody's like, why don't you drink? Yeah, so it's just a little thing like that. But I've never had anybody get really offended. I don't know. What was your experience?
Yeah, so most of, at least in our school, when we were at UF, it really was, they didn't talk about it much. Now, in my lower level classes, like Biology 101, my professor, you were an idiot. Like, you didn't have a brain if you didn't accept, wholeheartedly his agnostic and atheistic, and you would never become anything. You could never make anything of yourself if you didn't buy into this. So there was so much dogma associated with it. Wasn't like, hey, like in other classes you take them and there's not a physics and chemistry 101 and organic. There's not really an agenda in there philosophically, but once like biology, it's and the teacher doesn't pause and say, oh, by the way, I'm getting ready to talk about my philosophy of life. Like they start with the cell, but the question of and then all the evolution that comes along with that. But so many other classes that are talking about the sciences, they don't, there's not really that whole dogma approach to, hey, you've got to accept this philosophy.
Yeah, and that's a good point. I mean, I was clear through undergrad and mostly into grad school before, before I stopped being an evolutionist. So it was probably happening, and I probably just didn't notice it.
Right.
Okay. All right. Let's see. I'll go back to the. A lot of things we can. Let's see. Okay, so I think we stopped here. Okay, so now we'll talk some about radiometric dating, and these are the methods that are used to claim that say they were 4.54 billion years old, or the really long dating methods. And so the three assumptions. First is the degree to which radioactive carries to fluctuate throughout the life of the sample being dated. Typically, it's assumed that there's been zero fluctuations, and then now it's generally accepted that there have been small fluctuations, but most people, I think people that are really interested in it would know that, but most people still say they're constant. But this is key because, again, those fluctuations could have been much greater during creation week or the flood. I mean, to me, it's just things are so physically stable right now. The fact that something like that is fluctuating, would almost, I'd be very surprised if it wasn't fluctuating much greater during creation week or the flood. And then, of course, you have the original concentrations of isotopes being used to date the sample, and then addition or subtraction of isotopes being used to date the sample throughout the life of the sample. And so, these were some of the just the observations about. I think there are some course, even going back in the 90s, but it's really about 2006 where it began to be more publicized. And that was mostly the Stanford and Purdue results. I think we talked about those. And so this was for example, it's a Popular Science article from 2010. And it just talks again about Stanford and Purdue scientists, cortisone or nuclear genosperms are slowly on the surface. So this is one theory. This is what Stanford's kind of running with, is that it's something to do with something to do with neutrinos, but it could also be just a completely unknown particle as well. And so it's it's a real fast. I like it when you get quotes like this. Says towards the bottom there, it says, but it does not explain. I guess on Zoom, I think can you see my cursor on Zoom?
Yes.
Oh, great. Okay. So yeah, we're just here where it says, but it does not explain why the decay change happens. That violates the laws of physics as we know them. And so I actually like quotes like that because again, it's showing, there's so much related to science that we need to learn, which is fun, but it also means to question the Bible based on something we know is going to change. It's kind of obviously wouldn't make sense. And so that was a 2010 article. This was 2016. So this is just out on the Stanford News, and so he's this is I think when they first started talking about neutrinos, and then this was let's see, mainly just it's not nothing other than just just their focus going back towards towards using it for some kind of a neutrino research facility. And this was also astroparticle physics had an article. This is one where they mentioned the Ohio State with the chlorine 36. So just kind of put these out here. If someone gets interested, it's pretty easy, internet search, but they just look at changing decay rates, and Ohio State, Stanford, Purdue. I think there's data from Brookhaven National Lab, Federal Physical and Technical Institute in Germany, and then both the alpha and beta emitters are showing changes. So it's actually really exciting because it's none of this should be happening. I know it sounds really subtle, but I've got all the way through grad school, and decay rates were supposed to be absolutely constant. That's something you could count on, and then it starts getting reported that no, they change a lot, or they fluctuate. Okay, so then so this is the chart I was talking about discordances in estimated ages. And so these are Brahma and Fibolite. So it's at the bottom of the Grand Canyon. And so unlike rocks that, where you can just have one method of radiometric dating, they actually had three different ways you could look at them. And so this was, here they're using uranium lead, samarium neodymium, and rubidium strontium. And so, picture someone seeing this in their Earth Sciences book, and you look at these dates. So this is millions of years old. How old the estimate is in millions of years. And so you see rubidium strontium, it's at 1240 million years, so 1.24 billion years. Here's samarium neodymium at the 1.655 billion years. Here's uranium lead at the 1.883 billion years. So if someone just looked at this casually, they would say, well, three independent methods, they all say that it's more than 1 billion years old. And so therefore we know the sample has to be at least 1 billion years old. But that's a complete misinterpretation of the graph, because what's really happening here is you see these are the error bars. Okay, so what you have is you have three different estimates for the age, and none of those error bars don't overlap. And so I used my pen as the example before. So say I sent my pen off to a laboratory, and it said one lab said it's 100 feet long plus or minus a foot. Another one said my pen was 200 feet long plus or minus 2 feet. Another lab said my pen was 300 feet long plus or minus 3 feet. Okay, so I could say, okay, I know my pen's at least 100 feet long, but that'd be wrong. What I really should say is at least two of those three measurements are incorrect. And so here, we know two of these three have to be wrong. Right. I mean, and the reason that's so important is they're all, they use kind of the same assumptions for those dating methods. So there's a really good chance all three are wrong. Okay, so I don't know if that makes sense. If I have basically the same assumptions, the same general approach to radiometric dating, and I have three different ways of dating the same exact rock, so she gives the same age, and they all disagree, by definition, two of the three have to be wrong, but the other option is that all three are wrong. Okay, does that make sense? Okay, because that's so if someone and this isn't this is probably more the norm than the exception. I mean, sometimes the dates will match up. A lot of times they're off by. So we know there's something wrong with the just with the fundamental assumptions from that. So that's to me that's a point that can be made. And this is the helium retention in zircons. Okay, so what a zircon is, it's a small crystal, and when it forms, you can have a few % of uranium formed in that crystal, and then the uranium will decay to lead. And so again, the date that's estimated, that's usually based on what fraction of the uranium has decayed to lead. But in the process of uranium-238 decaying to lead-206, you also release 8 alpha particles, which is essentially your helium atoms. And so that's like we talked about, what you have then is two ways really of estimating the age of that crystal. The first is you could just assume that, okay, there was no lead when that crystal formed, and the uranium decaying to lead. You look at the current half-life of uranium-238, and based on what fraction of that uranium-238 decayed to lead, you estimate how old that sample is. But another way of estimating it is to go ahead and say, okay, how much helium was formed? Because if we make that same assumption, we know the uranium-238 decayed to lead. If we know what fraction of the uranium-238 decayed to lead, then we can know how much helium should be in that sample, or we can, we measure how much helium is in that sample, and then we know what the fraction of the helium, based on how much helium we know was formed and how much helium is still in that sample, we know the fraction that's been retained. And so that's the one where estimating the age that way gives very young ages. And so this chart over here on the left, when they say creation model, this is basically assuming that most of that decay occurred during creation week and the flood. And uniformitarian model says that most of that decay was spread out over several billion years. And so it's that's what you see then is, if you look at the actual data, which is the black dots here, you see the black dots, and then the theory, which is the squares, that's where the creation theory pretty much predicts the data. So you see the black dots, here, that's the actual data. This is what the creation model would predict. So it's pretty much dead on. The uniformitarian model, you're off by about a factor of 100,000. And so it's really, this is the exact opposite of an elevator speech. This is kind of like a desert island speech. I mean, because you're not gonna. But if someone really gets interested, they start looking at it. That's just another good indicator. And it again, if this is a stumbling block, if this is what's keeping them from objectively considering the Bible, then this coupled with the other, things like the soft tissue and dinosaur bones and the other factors coming in, this could be a way of encouraging them again to at least objectively consider the Bible.
That's great point. I think one of the things that's we've tried to emphasize in the class is it's not just the presentation of information, but it's actually the evaluation of the information. And so if a person presents the information in such a way that they don't disclose the limitations and things like that, or the deficiencies in the very instrumentation that they're using, a person in a class doesn't really have the they're at a knowledge disadvantage. If when you're a freshman in college and you're sitting in a class, you don't have the insight yet to evaluate your professor's position on things. You're just trying to take it in and pass the exams.
Exactly. Yeah. Yeah. You sit there with 5 classes, 2 of them are weed outs, and and you're just trying to survive. Then yeah, exactly. It's pretty much just try to repeat what you've been told. A lot of times, unfortunately.
Right.
Okay. Then so then I think the one let's see. I'll call it like a technical not really protest, but it just a point was, okay, but if the radioactive decay rates were greatly accelerated, wouldn't the resulting energy melt the earth? And so this is where, again, having to take everything into account. We don't know how those decay rates are accelerated. And so to me, this is actually, it's a really good clue if we go back and look at it biblically. We looks like there's been a lot of radioactive decay. Biblically, we know it's happened in the last few thousand years. And so that means those decay rates are accelerated. So then that in turn says that, however, those decay rates accelerated, and again, it could have been, God using the laws of physics that He created, or it's. But if we go that route, then that there would be less energy released per decay. So it's actually a big, big clue as far as how to. How that could have happened. And then another interesting one, and this I think goes beyond any definitive physics, and that's just this idea of stretching space. So the Bible talks about God stretching out the heavens. I think it's like 17 times. Okay, and so if you actually, if we assume there is actually a fabric of space, which a lot of people talk about, then if you stretch space, that's biblically consistent. Well, what would stretching of space do to not only to decay rates, but to the energy released per decay? And so that's beyond our current knowledge. And so that's so that would be, or I shouldn't even say knowledge. It's probably even beyond our current ability to make a slightly educated guess. So it's like, but those are some really good questions, because then maybe there is a way that we could go back. Based on the Bible, and just kind of get some feel for if I don't know, it'd be hard, but just what could that have, how much could a space have been stretched? How would that affect? Could that come into play during creation week? But anyway, so it's again just a lot of potential discussion points. It's kind of interesting. They have talked about accelerated decay rates. So every now and then you get an article like this. This was 2009. This is a CERN Courier. So that's the International Journal of High Energy Physics, and that's from CERN, very famous labs. So they were even noticing. They even noticed like ultrasonic cavitation speeding up thorium decay, and they reported it. So this is I guess mainly just put the things like this in to say there's a lot of things, unexpected things happen, where people are noticing they can accelerate decay rates. They mentioned some of the ways that, that decay rates are often accelerated, but this was just a new way that they had talked about. There was ultrasonic cavitation is actually very extremely powerful, but it's just a not saying that would necessarily have been the source of the accelerated decay. This is just kind of interesting. Some of the what we saw happening. This was I think this was Glen Canyon Dam started to get cavitation, almost destroyed the whole dam just within minutes. How fast that was eroding it. So it is very powerful. But again, it's you could conceive of it happening during the flood, but it's again not necessarily what would have been a way to accelerate the decay rates. This is I mentioned the inaccurate dates, kind of humorous but still damaging. So this was example. This was a 1954 eruption of Mount Negro in New Zealand. Potassium argon dates high as 3.5 million years. But again, if people saw that eruption, and so it's just kind of, oh, isn't that funny? It is humorous, but again, at some point, it just keeps kind of planting the seed that somehow the biblical ages can't be trusted, because again, the problem is if that eruption had occurred in the year 1500, it would have still dated at 3.5 million years, but then no one would have been around to say, oh no, that was a really recent eruption. so let's see, and then so summary on the radiometric dating. Again, significant evidence against typical uniformitarian assumptions, and so that was the fluctuations rate, decay rates we talked about, and that's a direct contradiction because the assumption is that they're constant, and then again the counterpoint is always, well, the fluctuations today are small, so it doesn't affect things too much. But again, things are very physically stable now, so it wouldn't be unreasonable to expect those fluctuations to be much larger during creation week or the flood. Carbon-14 and coal and diamonds, there's no way that can happen if coal and diamonds are over 100,000 years old. A lot of times you'll hear people talk about coal being 300 million years old, and you'll hear billion years every now and then for diamonds. Discordances in age estimates based on radioactive decay, that's what we saw at the Brahma amphibolites from the bottom of the Grand Canyon. Helium and zircons, that was the helium retention from the uranium-238 decaying to lead-206. Again, too much helium still in those crystals for that, for that process to have taken, 4.54 billion years. And then the significant errors dating rocks at known age, which was, of course, the volcanoes. And again, the accelerated radioactive decay during creation weekend of the flood could explain all of the discrepancies. And I phrase it that way because, again, the Bible doesn't say that, so I don't want to, say that's, but it is interesting that that's a pretty reasonable explanation. And it's actually a better explanation than a lot of, I guess you'd say the atheistic explanations. Now, I do want to go back. So I thought now, just related, that it might be good to jump to the Big Bang. Does that sound good? Or
That'd be great.
okay, all right. So let's and so this ties in because again, part of it is the this idea that again, if for the Earth to be 4.54 billion years old, you have these theories, and right now they're saying it's fluctuating a little bit. I think there's still the number that's thrown out the most is like 13.8 billion years for the estimated age of the universe. But we'll have, in this set of charts, there's people coming out saying that it's billions of years younger than that. And so again, it's still much older than what the Bible would say, but it's kind of interesting. If you go out on Wikipedia, they'll give 5 significant digits for the age of the universe. But then you can go read a published article saying they don't even know to 1 significant digit. So it's interesting. But anyway, so I started out on this, just, current knowledge of the universe is extremely limited. And there's problems, I guess, I'll call them just like standard billions of years theories. Those are recognized really all the way back in the 30s. Mid-1970s, a lot of evidence against standard theories being publicized. And I still remember this because I've always been interested in space and astronomy. And it was in the 70s. And there was so much evidence against these theories that they actually started proposing dark matter and dark energy. And it was actually fairly controversial because they said that 50% of the universe was going to have to be made up of dark matter or dark energy to basically keep there from being this fatal contradiction between what the Big Bang was predicting and what we were seeing. And and again, just reading various articles, but one of it basically came down to, they said, well, we're going to need to make that 50% right now, but that's just so we can refine the theory. And once the theory gets refined, that number will go way down. And so they had all these reasons why that was supposedly acceptable. But then, but that was the main one, was, okay, we have to start out at 50%, but then that number is going to drop. Well, it turned out the number actually went up. So now we're at 96% of the universe has to essentially be made up. Okay, so in other words, it's dark matter and dark energy has to make up 96% of the universe. And these are things that are just made up. This is a quote from our former NASA administrator, Mike Griffin. He said, what is the value of discovering that literally 95% of the universe consists of dark energy or dark matter, terms for things that we as yet know nothing about, but they make up 95% of our universe? Okay, so he was given that quote. He was given a dinner speech, and it was basically, he was just trying to people were saying, well, why should we explore space? And so that was one of the things he pointed out, was basically because we don't know anything at all about the universe. But we were talking about people that work really, really hard, really smart, really dedicated. Well, he's definitely one of them. I literally emailed him about midnight one night and just said, well, how would we, if we know nothing about them, how do we know they make up 95% of the universe? And so I was just working, I mean, I was working really late. I'm definitely don't usually work that late. But anyway, so I'm like, okay, I'll send this out, and didn't even figure he'd answer. Literally, I'm packing my stuff up, and within, probably 15, 20 minutes, he answers. Okay. So that's, again, just really hardworking, really dedicated. And so we went back and forth some, but it basically came down to, we know that 95% of the universe consists of dark energy or dark matter because it has to for the Big Bang to work. So you try to pursue that avenue, but at some point it's like, it's essentially saying the Big Bang doesn't work. And so that's what talk about the next few slides. And there's a lot of people starting to recognize that, but it's just kind of interesting because you'll see maps of dark matter, which I think is funny. You can't see dark matter, but I want to say it was National Geographic. They had this really nice color, big spread about, the map of dark matter a few years ago. But all it really is saying is here's where we have to put this fudge factor, which is basically dark matter, to actually make the Big Bang Theory work. So it was actually the fact that there was so much dark matter on this map was showing just how bad the Big Bang Theory is. But of course, it was fun the other way, saying, oh, wow, here's where we know where all the dark matter is. So it's kind of interesting. These are just some quotes. It says, it has been noted that the names dark matter and dark energy serve mainly as expressions of our ignorance, much as the markings of early maps with terra incognita. Current evidence favors models in which the primary component of dark matter is a new element particle called non-variant dark. Then dark matter, I love this bottom quote, dark energy considered even stranger. The only thing we know about dark energy is its name. So again, these are just things that are made up so that we can pretend the Big Bang works. And I don't know how else to phrase it. And then this.
Can I ask?
Go ahead.
So again, I think for us, it's important to see that dark matter isn't being measured. It's not something that they, what you're saying is that it's an assumption, right?
Yeah, and it's worse than that. We have no idea what it could actually be. It's literally. Let me go ahead. I'll jump to this. I'll jump to this one because this is what. So we have our observations, okay, and then we have these fudge factors, and that's dark matter, dark energy, inflation, all these different fudge factors we put in, and then we say that that's support for a theory. And so, but the analogy would be if I ask if x plus y is 100, what does x equal? Okay, and then I always tell everybody don't do algebra; it's too late at night. So just think of a number. Okay, so say someone says, okay, I think x is 20. Well, yeah, boy, they're absolutely right. X is 20, y is 80. The answer is 100. Maybe someone else says, no, I think x is 75. Good news is they're absolutely right. X is 75, y is 25. The answer is 100. If we do this, next year or something. And I come back in and I say, oh man, I'm really sorry, but the answer was really 200. Hey, no problem. Whoever said X was 75, Y is 125, the answer is 200. And so that's how the Big Bang is structured. It doesn't matter what our observations are. We can add dark matter, dark energy, inflation. They have dark flow, dark light. They've got all this stuff you can add. So you can pretend any set of observations support the theory. And if we change the theory, we can take that same set of observations and still pretend they support the new theory. So it's I will give this is good news. This is pretty old. I thought things were going to change a lot faster than they have. This is about 17 years ago. So this was an open letter to the scientific community. I actually published it in New Scientist. And it used to, I know it's still out on the internet. It used to be cosmologystatement.org, and it might have that website, the name of the website might have changed, but they're basically pointing out what we just said. So these are, there's about 500, I guess you'd say like professors, national lab employees, astronomers signed this petition. So, most of them weren't Christians, might have been no Christians at all. They were just saying, so they're not saying we should believe the Bible, but they're just saying we need to give up on the Big Bang. And so read this quote. It says, the Big Bang today relies on a growing number of hypothetical entities, things we've never observed. Inflation, dark matter, dark energy are the most prominent examples. Without them, there would be a fatal contradiction between observations made by astronomers and predictions of the Big Bang theory. Then it gets down and says, in no other field of physics would this continual recourse to new hypothetical objects be accepted. So that's pretty strong. They're saying that this isn't, this isn't physics. I mean, we don't, that's not accepted. And it said, very least, raise serious questions about the validity of the underlying theory. Then it goes on, says, what is more, the Big Bang Theory can boast of no quantitative predictions that have subsequently been validated by observation. So it's saying one of the things about a theory is it should be able to make predictions, and the Big Bang hasn't predicted anything. I was getting up at one of the, I think it was at the Air and Space Museum, and they said something about how the Big Bang, you would expect some kind of a, basically a cosmic background radiation. And we do see a cosmic background radiation, but what they don't mention is the cosmic background radiation we see isn't what you would predict from the Big Bang. And it actually made us introduce another fudge factor called inflation. So it's really, so anyway, just no quantitative predictions, subsequently validated by observation. Success is claimed by theory supports his ability to retrospectively fit observation with an steadily increasing array of adjustable parameters. Now this last sentence is a pretty neat sentence. It says, just as the old Earth-centered cosmology of Ptolemy needed layer upon layer of epicycles. So a lot of things in that one. So Ptolemy, of course, was the the philosopher that had proposed that everything revolved around the Earth. And so we started observing the planets. We'd make some observations, and we started figuring out that no, things aren't revolving around the Earth. And so rather than saying, okay, our theory's wrong, he or his supporters, I guess, they started adding what they called epicycles. And so they say, well, these planets must travel on, this, I guess is epicycle. So anyway, they basically had fudge factors they could add to pretend that Ptolemy's theory was still correct. And so several things there. Who usually gets blamed for the everything revolves around the Earth? Someone's trying to, they'll usually, that was the church or somebody. Well, no, it was actually Ptolemy. But we did apparently try to, some people at least incorporated that in and tried to incorporate quote unquote science, into the Bible, without reason. So anyway, that was one point. But the other one is just their whole point is we're doing the same thing with the Big Bang now. We're trying to we're just adding fudge factors to make the Big Bang work. So any thoughts on that? Because I kind of interrupted you. You're starting to.
No, I think it's very helpful in helping us to understand what it is, how it's, because, I think most people that are in the pews, unless they work in a field or they have a great interest or a hobby, they hear a lot about the Big Bang, but in terms of like sometimes we don't know, all right, this is theoretical, this is postulated, this is something that scientists are it's not always clear when they say, hey, we're guessing, or hey, we don't know, or we're just putting something out there. And you're really helping us see some of the light.
Great. No, thanks. Because that's, I think another way to think about it too is just this is the best we can do without God. In other words, like you can get in the whole thing, well, life had to make itself. Well, why did life have to make itself? Because the alternative is God made life. You can look information in the genome. Well, it must happen from mutations and natural selection, which we know doesn't work. That either is information neutral or information losing. But the alternative is that God put all the genetic information in the original created kinds. And so where did the universe come from? Well, God created the universe, and you have some things we can infer from the Bible, but they don't admit that. So this is the best they can come up with. So I almost look at it that way. A lot of these are just the best atheistic theories out there, but they're very, very lacking.
Right.
Let's see. This is a quote. This is actually reasonable for just a secular quote. This is University of California Observatory's lick, because it mentions although dark matter makes up as much as 85% of all the matter in the universe, astronomers do not actually know what it's composed of. And then it says, like this idea that stars just form from, gas collapsing on itself. Well, we know that doesn't work. So you have to put dark matter, gather it together, and then it attracts ordinary matter to form stars is the theory. That's why you need one of the reasons you need dark matter. Anyway, so a lot of probably too much detail for talking with a lot of people, but anyway, so there is stuff out there that if people are reading it from the perspective of, okay, is it like what you said, are we just speculating or do we really know what's going on? It's really clear that we're just speculating. Okay, so then we get a lot of questions on, so, dark energy is 93% of the universe. And so the question is, well, what if some alternatives were considered? So it's really interesting. These are two secular papers. This was a team of mathematicians. Says mathematicians come with an answer Monday for the mystery of dark energy tearing the universe apart and accelerate. It says it ain't there. Goes on and says, but what's interesting, it's so they come up with a way to eliminate dark energy. So just to think of the significance here, you have dark energy, 73% of the universe. We have no idea what it is. If you remember the quote back here, it says, it says dark energy considered even stranger. The only thing we know about dark energy is its name. So we have absolutely no idea what dark energy could be, right? So they've just come up with a way to basically eliminate the need for dark energy. So that would normally, you think that could win a Nobel Prize, right? I mean, just, that's a huge physics breakthrough. But they say the only problem is that for the equations to work, we must be literally at the center of the universe. Says physicist Lawrence Krauss of Arizona State University in Tempe. It doesn't seem physically relevant. Okay, so the question is, why isn't that physically relevant? Okay, so this was a team of mathematicians. So here you have a team of physicists, and they come to the same conclusion. They say that if the Earth is near the center of the universe, we don't need dark energy. Okay, so this says the article goes on to note, but that scenario violates the Copernican principle, a notion near and dear to the hearts of physicists and cosmologists, including Caldwell and Stebbins. Okay, so again, what we're dealing with here is you have a case where you eliminate a 73% fudge factor. In other words, right now, 73% of the universe is having to be made up with this dark energy. You get rid of the need for that, but you're not allowed to consider that because it requires the Earth to be in a special place. So that's the Copernican principle. Copernican principle, it would sound technical, but again, it's actually, it's just a purely religious principle. It's got nothing to do, nothing scientific at all about it. It's basically saying that we have to be someplace random, because if we're in a special location, that might imply the existence of God. Okay, so because of this religious principle, we're not allowed to consider a solution that basically allows us to get completely rid of dark energy. Okay, so that's how to phrase it. So that's, I guess you just say, like I said in the title here, just atheistic theories hindering scientific progress. But so what gets even more interesting though, and there's a good a physicist from Sandia National Laboratories, he's retired now, was Russ Humphreys was his name. He actually pointed out that if the Earth was near the center of the universe, then a straightforward reading of Genesis would say during creation week, the Earth could have been in a timeless zone. And that's basically, essentially think of that as inside the event horizon of a black hole, the equivalent. So if you get that situation, then that would explain very well how the universe appears the way it does from an Earth that's a few thousand years old, and also eliminates the need for dark energy. So now all of a sudden you're thinking, hey, this is at least worth pursuing. But as far as I know, both of these lines of thinking were dropped because of this requiring the Earth to be in a special location. So anyway, that was kind of a monologue. Any thoughts on that?
So that's interesting that you can't appreciate it for what it's worth. For seeing things as they are, it seems like that you've got to stay committed to the explanation, regardless of what the data is showing.
Right, exactly. Yeah. So if you just looked at the data, you'd instantly conclude, wow, the Earth must be near the center of the universe. And as a Christian, that God had to put us someplace. So that, that's, it doesn't seem unreasonable. And so this is actually when I'm waiting for the atheists to make the switch, because there's also a lot of reports coming out how we're, there was one, I think Oxford University published like 2 years ago saying that, it looks like we're alone it literally says there's a good chance we're alone in the universe. And so that goes totally counter to, what was it, the Fermi paradox, where he was like, where are they? Talking about, why aren't we finding all these civilizations and everything else? So I'm waiting for them to say, okay, life must only be able to evolve if you're near the center of the universe. Therefore, we're near the center of the universe because we all know life evolved. And then, then you get rid of the need for dark energy and you get a cosmology. But they haven't no sign at all they're making that switch yet. But it's pretty obvious to me. We have, because this was some of those earlier quotes. They're getting close to 15, 20 years old. We still have absolutely no idea what dark matter could be or what dark energy could be. We're always, I think we're even running out of things to try to guess at. And so if you can't even guess at something dark energy is, then just go ahead and say, okay, the Earth's near the center of the universe. A lot of them don't make the jump, but during creation week, just straightforward reading in Genesis, and especially coupled with God stretching out the heavens, you actually end up with you end up using gravitational time dilation and some other things, but you end up with the universe looking exactly like it is from an Earth that's a few thousand years old. So it's kind of, it'd be fun if we were at least allowed to, or obviously we're allowed to investigate it, but it'd be fun if a lot of other people were too.
Right. So let me, I hope I don't derail you too much by this question here. So what I'm trying to think of climbing into your brain and working with NASA for a moment. And we've talked in classes past about fine-tuning principles, and the distance we are from the sun, our the distance we are from the moon and its impact on tides, and then the fact that Jupiter with cosmic debris kind of protecting us from things like that, like what Kepler said, he was thinking God's thoughts after him. So take us into your, if you're talking to a non-scientist and you're a person who doesn't have a scientific background, what fine-tuning principles are you really kind of delighting before their minds in terms of letting them consider, hey, think about this? Like what are some of those that you would share with them?
So it's so one of the ones that's so this would be one approach. It's not necessarily a fine tuning, but right now one of the reasons we can't send people to Mars, I mean, is some technical challenges. So a lot of people are interested in going to Mars. That's always a big, even Hollywood, like the Martian and stuff. So there's a lot of technical challenges we could probably overcome, but they have what they call planetary protection. But the idea is that it's not to protect the astronauts. It's that what if there's a bacteria trying to evolve on Mars, and then we go there with people and we introduce bacteria, from us, and our bacteria kills it, or, so it all centers around this idea that life might be evolving on Mars. And so it's actually right now, it would be at least against a lot of agreements and policies to send people to Mars because you'd contaminate it. But it gets, so like even our rovers, we're not allowed to like dig in the soil where there might be water. Well, if we're going to send astronauts there, you actually want to go where there's water. Yeah. So we're really hindering ourselves from an exploration standpoint. And so that's so frequently you get the opportunity to say things like, we've really got to, we just have to admit that there's no way life could just make itself. And that's a statement. And pretty much everybody, you can get kind of a little bit of an uncomfortable silence, but no one's going to counter it for two reasons. First of all, everybody knows life can't make itself. But also, you're on this conversation about, boy, it sure be nice if we could, just for, try to put people on Mars or do an outpost there. So it gives a good segue in there. So that's probably a really good way. If you have a friend like that, you get them, just go, you can look planetary protection, or NASA even has a planetary protection officer. I mean, you can search online and just, if someone's really into like human exploration of space, that's a good topic. Because right now we wouldn't be allowed to send astronauts to Mars just based on that policy. And so that's, one way in now with the Big Bang. Let's see, this was, I think, okay, so we talked quite a bit about this slide. Okay, so, and then this is another one. This is at one of the articles from AP about 2 years ago. Again, just about how little we know about the universe. And again, they're saying, even though they're saying the universe is looking younger every day, new calculations suggest the universe could be a couple billion years younger than scientists now estimate. But again, it's still older than the biblical ages. But it's just the point that we know so little about the universe. But I think related to the Big Bang, I think one could be that it's always, we talked about in the beginning, God created the heavens and the earth. And so that answers the question about who made God, because in the beginning, means God created the dimension of time, not just the heavens and the earth, but he also created time. For God to have created time, he has to be outside of time. And so then by definition, anything outside the dimension of time can't have a beginning or an end, which is very biblically consistent. So everything that's ever been proposed for initiating the Big Bang has always been an appeal to the supernatural. And so it used to be 20 years ago, they would talk about a point of infinite density where the laws of nature don't apply. And of course, where the laws of nature don't apply, that's, again, supernatural. Now there's actually talk about things like multiverse generators, and maybe there's a multiverse generator out there that's generated an infinite number of universes, again, trying to play that mathematical trick with infinity. But again, it's outside nature. So it's an appeal to the supernatural. So that would be one, maybe just, pointing out that there's always this appeal to a supernatural. But the fine tuning one, to me, it's kind of summed up with this one. And so I'm trying to think of how to get, so basically what they're saying is, even the atheists admit that our universe is incredibly finely tuned. And it goes, everything that you just mentioned, everything from, Earth's position to the sun, even just locally, but even at the scale of the universe, everything's very finely tuned. If you change the electromagnetic force or the strong force of the, strong nuclear force, weak nuclear force, anything you might change, you basically, the universe doesn't survive. And so what's happened is now the atheists are stuck with what they call the Boltzmann brain problem. And I wouldn't have even believed this one is so strange, except, I went out heard about it, went out on Wikipedia. Sure enough, I think pulled this one off of Wikipedia. I'll try to read it sentence by sentence. So if our current level organization having many self-aware entities is a result of a random fluctuation, it is much less likely than a level organization which only creates standalone self-aware entities. And so what it's basically saying is our universe is so finely tuned. And of course, they go on to say that we must have evolved and everything else, that the odds of a universe just popping into existence is much, much smaller than just an individual brain popping into existence. I mean, like almost, I think someone here talks about even infinitely, it says vastly outnumbered. I think some of them say, anyway, because but so essentially what they're saying is the probability is close to 100% that, from my perspective, you guys aren't actually there. In other words, I'm just a brain that's popped out of the chaos. I'm imagining absolutely everything, everything from my childhood to, where I'm sitting to, having a great Zoom conversation. You guys, it's all just, hardwired into this brain that's randomly popped out of nothing. Because what they're saying is that's essentially infinitely more probable than a universe as finely tuned as ours popping into existence and letting, stars and galaxies and planets and life and everything else form. Okay, so that's kind of a culmination of the fine tuning, but it's really strange. I don't know how else to phrase it. Had anyone heard of the Boltzmann brains before? Okay, yeah, it's I'd heard people say that Ego in Guardians of the Galaxy 2 was supposed to be a Boltzmann brain. So, but I'm not sure if it's worth watching the movie over. But it was, if you want more information on the subject, that might be a place to start. No, I'm kidding. It's just, it's really strange. But this basically what they're saying is the odds, our universe is so finely tuned that the odds of it popping into existence from the universe generator or whatever they say made it pop into existence. They're saying that's essentially zero compared to the odds of just a brain popping into existence.
Wow. What a comparison.
Yeah. Yeah, exactly. And then they're both obviously zero, and they both require an appeal to the supernatural. And oh, by the way, their universe generator can't give me the ability to choose, you know. So it's so that, you know, that's, you know, only God can do that. So it's kind of strange. So any questions? I guess any questions on anything we talked about tonight, or?
Could you comment a little on black holes? Are those real? Are they theoretical? Or what, do they play any role in the discussion of the Big Bang and things like that?
Yeah, so they should be real, you know, and I think we have you know, evidence, you know, that we, you know, like matter on the edge of a black hole behaving the way we would expect it to. And it's just, you know, such a high gravity field that the escape velocity from the black hole is greater than the speed of light. And so you get all kinds of strange things happen inside what they call the event horizon of a black hole. And so, for example, during creation week, you know, when it talks about, you know, spirit hovering over the face of the deep, and yeah, that if like say all of the mass that God put in the universe, you know, it was there, then that would have been really far inside the event horizon of a black hole, and that would have. So again, this is don't want to go off on the, you know, it was obviously creation week was miraculous. But in that situation, that ends up with a really good explanation, again, of how we see the universe, the way the universe appears from an Earth that's a few thousand years old. But yeah, so it's, so yeah, black holes, we're pretty confident, you know, or I'd say really confident they exist. And it's, you know, but it's yeah, it's just one of the, just kind of like stars and planets and everything else.
Dr. Houts?
Yeah.
This question was actually asked by my nephew. I've heard a lot of people think, well, I'm not going to quantify the number of people, but I have heard frequently people express that they don't think that the Bible and science have anything to do with each other. And you've already spoken to that this evening. In addition, my nephew pointed out that sometimes Christians want to listen to science, and sometimes Christians don't want to listen to science. And so if you were presented with that question, how would you answer it?
Okay, so
I admit I have failed.
Yeah.
That makes sense to me.
So I would say, you know, true science is always the Christian's friend. True science is always consistent with the Bible. And so when we talk about fake science, I think the classic example is this idea that, you know, when someone says life just spontaneously arose 3.8 billion years ago, that's completely non-scientific. So why would I, you know, and no one, I mean, I've never had someone claim it is scientific, because when you think about it, again, that's, it's the simplest life is more complicated than a space shuttle or you know, an airplane. Today you say a Falcon 9, you know, whatever, you know, the person is talking to. And so to say life could just make itself, that's worse than saying an airplane could make itself or a computer could make itself. And then if someone wants me to prove that my computer didn't just make itself, I mean, I might, you know, be a fun kind of strange discussion, but it's got nothing to do with science. You know, so likewise, if someone's trying to make a Christian prove that life couldn't make itself when claiming that somehow the idea of life did make itself is scientific. I mean, it's not so that's fake science. It's the whole idea of information being added to the genome by mutations and natural selection. That's fake science. I mean, it goes against everything we're observing, that'd be a whole nother discussion. But you look at every example of evolution in every book, it either has nothing to do with evolution or it shows the opposite of evolution. And so it's so again, if someone says, like peppered moths, why don't you want to? Well, you love talking about peppered moths, but just point out that, hey, the genetic information was always there, or Darwin's finches, no new genetic information always there. So I think Christians are always happy to talk about truth science. And so you almost ask them, maybe just ask them what they mean by Christians not wanting to talk about science. I think, atheistic speculations that go against science would be too harsh of a response. You want to, keep the person engaged, but it's there really isn't. I think every true science topic Christians would really, love to talk about. Maybe if we're allowed to talk about the Big Bang, I think that's good to talk about. But just allowed to show both sides of, if we're fossil records, great to talk about. You can have all of the, just the evidence that the fossil record was laid down during the flood. The radiometric dating, again, just immediately jump to the, if they just say, well, this person dated this zircon and it was 1.5 billion years old, then we should be allowed to say, well, did they measure the amount of helium inside the zircon? And that's a scientific discussion, but it usually just doesn't go that way. So I don't know. I would just say, well, and then back to what your first part, obviously it's the Bible is God's inerrant word. So, it's anything that contradicts the Bible, obviously we know is wrong. And so that's, when we, but true science doesn't contradict the Bible. But so the Bible does, in some ways touch on science, 4.54 billion years old, or someone says life made itself, or someone says life evolved from bacteria. Of course, that all contradicts the Bible. I don't know. That's a tough one. It's so individualized. Trying to see what they're getting at. Right.
Yes. Well, thank you. I appreciate your comment.
Yeah. No. Sorry. I kind of just ramble on stuff like that. So I should have never. It's so much dependent on the individual. But it's great they're talking to you about it, though. That's a great sign.
Yeah. I'm going to try to get him to listen to this lecture.
Yeah, that'd be great. Feel free to have him send me an email or anything if you'd ever like also, but it's
yes. I put your contact information in my phone already for that explicit purpose.
Oh, awesome. Okay, great. Yeah. And then again, just a little tongue in cheek, but just ask him if he says he doesn't want to watch, well, I'll be optimistic. If he says he wants to watch it, say, well, did you choose to want to watch it? And we'll say, yeah, I chose. And he's like, hey, there you go. You got it.
Houts, we had a comment from one of the students, and I'll just share a couple of them with you. One student said, it sounds like the evolutionists are the ones taking the leap of faith that's based on made up things, and that they are digging in and defending their position when they would claim that Christians are, taking a leap of faith, and we're trying to base our understanding on what we find via the evidence. So yeah, that kind of goes along with Mary's point.
Yeah, exactly. Yeah. This was along the lines of the true science being the Christian's friend. So there's a lot of examples we could use, but I always try to go back to, if you look at things historically, so this was 1907. We're going into that time of year. It's hard to argue. We're almost into November. So, you start getting those end of the year stories and what was the most significant event of the past, year and everything. And so this was the 1907 Wall Street Journal one. And I love the quote. It was the most extraordinary event of the past 12 months was the proof afforded by astronomical observations that conscious, intelligent human life exists upon the planet Mars. And I got to say, boy, that would 100% get my vote too. But that's 1907. What was really funny was that was actually that's a rock in the upper right. That's like a 4-inch tall rock, but it was right when I think we took that photo. Right, it was one of those Star Wars movies came out where they had like the sand people. I think they called them or something. So anyway, you can imagine that was one of them. But anyway, it's but. So, science advances, and this was the reason they did this was, of course, you had Percival Lowell. He was he was one that sent this team to the Atacama Desert, and he told them to observe canals, and sure enough, they did, and they were convinced they were Martian civilization, established facts, and everything else. But the point is, science progressed. So even in 1950s, you had Walt Disney. There's a good, it's out on YouTube, in 57 was, that's supposed to be on Mars, on the lower left here. And, you had these strange plants, and, maybe there were people, but even if there weren't people, what would we find there? And Collier's had a lot of, is there life on Mars? Well, then True Science, we start getting, okay, there's Mariner 4, there's Viking. Now we've got the helicopter. We know there's nothing on Mars, but it's just kind of, so Christians wanting to discuss science, maybe a way to look at it would be, if they wanted to say in 1907, well, what about these humans on Mars? Did they escape the flood? Did they escape God's judgment? Did they evolve there on their own? Did they? And if the Christian said, well, I don't know if I believe any of that, then we'd be accused of not wanting to talk about science. But of course, science advances and it confirms the Bible. So that's maybe an analogy. And then just while we're, just had, this was that quote, are we alone in the universe? So this is Oxford University. I don't want to read the whole thing. It's basically, you notice they're basically having to backpedal, because it was Enrico Fermi. It's probably, I don't know, it's been at least maybe even 70 years ago when he had his famous quote about where are they? But so this whole paragraph, when we take account of realistic uncertainty, replacing point estimates, probabilities, et cetera, keeps going. We found qualitatively similar results, and here was their bottom line. But it's kind of, rather than just saying, hey, we've been wrong for the last 80 years or 100 years or 150 years, or keep talking about all these civilizations. Now they're saying, let's see, I think it says perhaps find a substantial probability we are alone in our galaxy and perhaps even in our observable universe, up to 99.6% chance. These are all atheists, of alone in our galaxy, and 85% alone in the observable universe. So it's true science advancing. So that's why true science is the Christian trend, because biblically, it's very biblically consistent that we're alone in the universe. But you go back 100 years, and it was just we thought there were going to be civilizations everywhere. And in the 60s, we kept, every time we turn on a radio telescope, we think there are going to be civilizations everywhere. So anyway, so just kind of an aside, but you can do that, all kinds of things where just you look what we were thinking 50 or 100 years ago compared to what we know now, and true science always confirms the Bible.
Right. We had one other comment I want to put out there that I'd be interested in your comments on. One student writes, many people assume that all things started at age 0. A God that has the power to create the universe would have the power to create things at any age he chose. I think that's what was being said there. We know that the plants, animals, and humans he created were all created beyond age 0 because they could immediately reproduce themselves. So I'd be interested in your thoughts on that.
Yeah, no, that's an excellent point. Yeah, and I agree completely. That's it's a lot of what we see in creation was created mature, and so then it's just, and I think like say Adam and Eve and plants and animals and the earth to some extent, or actually to a great extent, everything created mature. And then, so I said, what's the, I think the portions of creation created, mature is a very good explanation. And then I think a lot of other things that might present some difficulties, I think it's just, it's where we're at with our understanding of physics. So for example, like the radioactive decay, I think it's, we just very recently understood that those decay rates can fluctuate. And so, and that's a very good explanation for the, what we think we're seeing, as far as radioactive decay that's occurred on Earth. And then when people say the classic question is like, okay, we're seeing stars that are, hundreds of millions or a billion light years away, or, so how could you do that from an Earth that's 6,000 years old? So a lot of ways that could happen. that could be mature creation, but also, I lean towards the gravitational time dilation. I always have to step back and ask myself, well, why do I lean that way? And I really don't know, other than just that's really pushing our understanding of physics, but it gives an excellent explanation. And it's almost like, it's like again, the more we explore God's creation, the more it glorifies God. And so it's always interesting to think, okay, if as our understanding increases, that's going to point us back to God. I keep doing this to you guys. I want to go back to another one. Let's see if it's so this was, this was life in 1876. This was Ernst Haeckel's History of Creation. And so again, it's the same thing. We barely had microscopes. We didn't know about DNA. We didn't know about anything scientific related to life. And so he actually published this whole book, History of Creation, which was kind of his alternative to the Bible. And so you read this quote, and of course he's trying to explain where life comes from. He says, and he's a lot of the more popular atheists are very eloquent. I would never think to phrase sentences like this. And so it's almost a entertaining way of writing. But he says, during late years, we have become acquainted with Monera organs, which are in fact not composed of any organs at all, but consist entirely of shapeless, simple, homogeneous matter. The entire body of one of these Monera during life is nothing more than a shapeless, little lump of mucus or slime. Consistent in albuminous combination. In the last sentence, simpler or more imperfect organisms we cannot possibly conceive. Okay, so he's basically, and he's got, you see the color plate. This is actually pretty high tech for the late 1800s. So he's even claiming that he's observed them. He's got this in his book. I've got a copy of the book. It's kind of interesting. It's actually very convincing. And then he goes on. He talks about all the Monera he's examined and where all he's found them. And of course, this is when most people in the world hadn't traveled probably more than 10 miles from where they were born. He's talking about, Canary Islands, Straits of Gibraltar, all these places off, off the Norwegian coast. Talks about Huxley, also finding, Monera. And then, of course, it was literally, I think it was before he'd even published his book, where everybody figured out that they were all fake. Okay, so it's, and so, so all that to say things like that's why it's tempting to. So, if you'd read that in 1876, it'd been really hard to refute. So that's likewise. It's I guess where I was going with that is I just think there's, with the universe and mature creation and how creation is done, there's so much stuff we don't understand. We're kind of like with our knowledge of the universe, frankly, probably about where our knowledge was back here in 1875 with life, and maybe even less on the universe. So I guess all that was just to justify my fascination with, hey, why don't we apply things like general relativity or other things that we're just starting to figure out, but that doesn't mean at all that a lot of things weren't created mature.
Right. Yeah, that's a great point. And to hear you talk about, because you have a perspective on what we know and what's being explored, and you're there on the cutting edge of what scientists are trying to uncover. And maybe someone else in the class has a question or comment tonight. Anybody have anything they want to add? I've really enjoyed your presentation tonight, Dr. Houts, and it was, very informative, very thorough and detailed. We were really looking forward to this class, or I was really looking forward to this class, and we were advertising it pretty heavily throughout this semester about you coming, and so you've really helped us with some understanding in these areas, and we've been blessed immensely from your understanding, and we can hopefully, now that we have your information, would it be okay if we were able to get a copy of your slides?
Yeah, that'd be fine. Yeah, I can send those out. And then it's please contact me anytime. There's good information out on Apologetics Press, and it's but you really love talking about this. So I actually really appreciate you giving me the opportunity to talk to the class and have the discussion, because to me it's a real important topic. I mean, any area where people, I guess to say, where society tends to attack the Bible, I think is really important. And to for us to be able to defend, and that's one where you have. Well, again, I think we talked about when we were talking about near the start, we we're talking about the soft tissue and dinosaur bones, and again, it's really we assume our children are not being led astray or not being basically not being misled. But boy, if you ask them certain questions, they always give the it's not their fault, it's nothing against them, but they'll give the secular answer. And so so it's just this area, just the whole idea that somehow science is against the Bible, that's unfortunately kind of a popular way to attack the Bible these days.
Right, absolutely. Well, thanks so much for all your time. We're going to end with a prayer, but we want to tell you how much we appreciate you taking time out of your night to share a piece of your time with us and your life, and also helping us to understand some of these issues that are technical, but also giving us ways we can have conversations with people when we when they aren't really sure on, or when they're certain of an old earth, but there's also some assumptions that they may have accepted but never really been challenged on. So we thank you for taking time out to share that with us.
Well, again, my pleasure. Thanks a lot for inviting me. Really appreciate it.
Absolutely. Okay, well, let's have a